Ever wondered how scientists figure out the age of ancient artifacts? Or even how long ago a living creature died? The secret lies in something called carbon dating. All living things, like plants and animals, absorb carbon from the environment. Carbon has three naturally occurring isotopes: carbon-12, carbon-13, and carbon-14. Out of these, carbon-12 and 13 are stable, and carbon-14 is radioactive. A radioactive element is an atom whose nucleus is unstable and spontaneously breaks down, releasing radiation in the process. Since carbon-14 is an unstable radioactive isotope, it decays spontaneously into nitrogen-14. Carbon-12 is the most common form of carbon in the atmosphere. Roughly 98.9% of all carbon is carbon-12. Carbon-13 is about 1.1%, and carbon-14 is incredibly rare, roughly 1 atom per trillion carbon atoms. When a living organism absorbs carbon, it absorbs all three isotopes of carbon in roughly the same proportions as they exist in nature. So as long as an organism is alive, the ratio of carbon-12 to carbon-14 within the organism remains constant. But when the organism dies, it stops taking in new carbon. The carbon-14 it already has starts to decay, changing into nitrogen-14 at a very predictable rate. But the amount of carbon-12 remains constant even after the organism dies. So, we measure the ratio of carbon-14 to carbon-12 in the sample and compare it to the ratio in living organisms, which is assumed to be constant. This helps us determine how many half-lives of carbon-14 have passed since the organism died. The half-life of a radioactive element is the time it takes for half of the atoms in a sample to decay into a more stable form. Each radioactive isotope has a specific half-life. The half-life of carbon-14 is 5,730 years. So, using the ratio of carbon-14 to carbon-12 and the half-life of carbon, we can calculate how long it has been since the organism died. Carbon dating is incredibly powerful for dating organic materials up to about 50,000 years old. It's a brilliant way to uncover the mysteries of our past, one ancient atom at a time.